So we'll continue our discussion today, and the topic which we are going to discuss initially today is called as the outlier detection. Outlier detection and the removal. Okay, so let's look at what is an outlier and how do you detect the outliers in the data set. So far, it should be very clear that our intention is to do the analysis of certain data and obtain the insights of the data. So in order to achieve that, first thing is that you need to collect the data, right? Let us assume that we can collect the data from various resources, right? So one of the possibilities is that, right, you simply collect the data which is available from the internet, maybe the simplest way, right? So we have two options over there. When you collect the data, you may get the data which is specifically in the structured format and the processed format. You don't have any outliers in the data set. Normal, right? When you collect, there are two possibilities. First one is it's a clean data. Cleaned data. Somebody has worked on that. They remove the outliers. They remove the not in numbers, right? Etc. Many outliers which are possible. They have removed it and it is available in the format. That's the first thing. And the second option is that, right, let us say you are not collecting from the internet and you build, let's say, maybe you are collecting by yourself by building a circuit, possible, right? So I want to collect the various data set coming from various channels of a circuit which actually senses the parameters surrounding environment, like temperature, humidity, the pollution, UV index, etc. Maybe I'm building a circuit, right? Very simple circuit we can build. Otherwise, maybe you use the standard Raspberry Pi or say the Arduino, right? Etc. Various platforms are there which you can interface various sensors and let us say you try to collect that data, right? So what happens, right, is there is a parameter, noise parameter related to each and every sensor that you are going to use, right? So that means whatever value may give, there is a possibility of noise affecting to that, or because of the fluctuations in the voltages, currents, and many other things, right? The data that it senses, right, may not be the actual point, right? One of the value at say in 1 minute, you may sense say 1,000 values, right? Out of which, let's say one or two values are actually not proper, right? So instead of sensing 1, 2, 5, 1, 2, 3, etc., there is a small range because within 1 minute of time, your temperature may not rise by a huge factor. That's not happening in a normal environment, right? So the idea is that my temperature is being sensed and it's coming like 25, 25, 25.1, 25.2, 20 because of some noise, something, right? Some volt, because everything is controlled by voltage and current, right? So every sensor's output, it's a transducer. Its output depends upon voltage, current plus some other parameters, some internal parameters, right? So because of which there is a chance that you get an outlier. Like instead of giving the same range 25.1, 25.15, 25 point like that, all of a sudden you get a 50. It's not correct. I because immediately next value is again 25.35. So all of a sudden you get a, those points are what we are going to talk about now. So such points, right? It's coming not because of a fault of a machine, because of some characteristics, right? It's not. I cannot say that it is a faulty device, right? If device is faulty, you will get the higher values or a lowest value, right? Continuously. All of a sudden, somewhere in the middle, I get a one such value. If you have, say, 100 points, maybe you have 1 or 2 points. So it is important to identify such outliers. Right. So once you detect that, then you can remove. Removal is actually not a, it's left to us. In the programming itself, I can do something, and I can directly eliminate, right, those detected outliers. Now, there are various options available, right? So let us go to the one method which is used in the statistic itself, right? It is called, by using a parameter, the parameter is called as, right? I'll write this here. So by using what is called as IQR, okay? So that is inter quartile interquartile range, right? We need to calculate a parameter that is called as IQR. Using that, we will be able to detect the outlier. This is one of the very standard procedure that is used in statistics. Okay, so let's look at that with an example, and then we will go for the programming as well. Okay, we'll do today. Will be a programming session. There will be programs coming up. Right? We'll be writing the programs. Okay, so let us consider the data in the following format, right? So let's say there is a parameter, let's say variable x. Okay, so x is, we'll write in this way. So 1, 2, 2, 3. Okay, let me write another 2 here because what I already have calculated something that actually takes a, right? Yeah, so 3 times 2, then we have 3, 3, 4, then let's say 5, 5, 5, 6, 6, 6, 6. I'll write it below. 7, 8, 8, 9. Maybe all of a sudden I'll write it 27. So if I ask you a question, what is the outlier over here? Let me assume that this is the data set what I have. So definitely you will immediately say that yes, 27. Okay, anyway, as of now, this is a very simple example, and again, we are not considering hundreds or thousands of data points over here. I'm considering maybe hardly say maybe 10-20 numbers are there here possible. Okay, so as soon as you see, you will understand that okay, 27 is that's correct as well. So now let us see how do we identify mathematically that okay, this number is an output. So I may not be able to define something like find the maximum out of it, right? And that is an outlier. I may not be able to write that as a code. Provided if there is no 27, then it will remove 9 as well. But 9 falls within the range. It's still a single digit number, right? So I should not be removing 9 as an outlier, provided 27 is not there. As of now, 27 is there, so 27 is an outlier. But still, okay. So again, one thing is that when I'm dealing with a larger set of numbers, right? Not like just 10-20 numbers, say 1 lakh numbers are there in my data set. Let me see. In such case, it is impossible to go for each and every number and check that, right? Will it be an identifier, right? In a single screen, I may not be able to see 1 lakh numbers also. I may have to scroll down, 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 down. So when you reach the last value, you might have forgotten what's there in the initial few pages of the data, right? So in this case, in this example, it is very straightforward that yes, we identified that this 27 is an outlier. Okay, but that's not the case in a on a real time on real data. Okay, but anyway, so we for this case being very simple, we could identify that. Okay, so in order to identify whether a given what you call what is the that is what's the outlier, already I mentioned that I need to calculate IQR, right? How do I identify IQR? We will need to calculate that. So for that, let's do one thing. So let us first calculate, right, what is called as the Q1. Okay, Q is it's a quarter one. In the sense, I need to consider, see the whole data set. If you consider the total length as 100%, I can calculate, right, that I can split that into 4 quarters, correct? So 4 quarters is 25%, 50%, 75%, and the last part will be 100%. So there are 4 quarters, out of which the first quarter's last element is what we are talking it, and this is the Q1. Q1 means, right, let me try to write that. It's the first quarter. That means it corresponds to 25%, right, of the length. Okay, again, I also need another one that is called as Q3, right? This is the third quarter. So that corresponds to the 75%, right? So Q1 25, Q2 is 50, 25 to 50, Q3 is 50 to 75, and the Q4 is 75 to 100. Out of that, now you see, I'm looking at only two of them, Q1 and the Q3. Okay, so why we are doing that? Because IQR requires these two. That's the only reason. Anyway, I'll come to that. So let's calculate Q1 now. So before that, remember one thing, irrespective of how you have your data, now I already have sorted my data in the increasing order. This is important. Okay, so already it is done, so I'm not doing that. But if it is not there, you need to do that. Okay, remember that will be the normal first step. Whenever we are proceeding with the outlier detection and removal using the IQR technique, please remember data set needs to be arranged in a sorted format, ascending order. Right, it's already there. So right, so once you have done that, calculate the Q1 and Q3. So in order to calculate a Q1, right, I need this, right? So Q1 can be calculated. It's a 25th, so like 25%, that element, right? When I start from the beginning, what comes over there? So that is actually 25 out of 100 into 25 by 100 into, find out the length of this data set. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, so please calculate that 0.25 into 19. Right, so you can see that you get 4.75. So I'm looking for the integer value. So 4.75. Let's do one thing. Let's approximate. Okay, I'm looking for the fourth element. The next possible is the fifth element. So I will convert that into 5. So fifth element. Okay, so Q1 implies the fifth element, right, in the along your data point. So calculate the fifth element. So that is 1, 2, 3, 4, 5. Can you see the 3 is the fifth element? Okay, so this is the Q1 for. Similarly, I need to calculate the Q3. All right, so let's calculate the Q3. Q3 means what? 75% of the total length, whichever lies over there. So 75 means it's a 75 by 100, 0.75 into the length. Okay, so let's quickly do that. So that is 0.75 multiplied by length is 90. 14.25. Okay, so that is 14.25. So 14.25. Normally we do an approximation. If it is lesser than 0.5, we'll come back to the smaller value. So approximate that to 14. Right, look at the 14th element in the list. So this is fifth one, 6th, 7th, 8th, 9th, 10, 11, 12, 13, 14. All right. So 14th element will become 6. All right. Okay. Now we'll go for, right, what is called as the IQR. So remember those values. I'll write that here. So Q1 become equal to 3, right? And similarly, let me write the Q3, right? Q3 means it is the 14th element. And how much we got? I think 6, correct? Okay. All right. So let us apply that and let's proceed further. So let's define the IQR, right? Using the Q1 and Q3, once you have, you can calculate what is called as the, therefore, IQR is equal to Q3 minus Q1. Okay, that is 6 minus 3 equal to 3. So interquartile range for this given data set is 3. Always the formula remains same, Q3 minus Q1. For Q1, already you know what is the formula. For Q3, already just now we have used the formula, 75% and the 25. Okay, all right. So again, let me remind you something here. There are different versions of this. Some of the references may take the next element as well. Don't get confused with that. So instead of, say, they say that I got, say, fifth element, take the sixth element, because fifth element may become, right, maybe in the previous quartile, I want to take the next element. Absolutely fine. There are some smaller changes so in the versions of each researcher. Okay, so when you refer another textbook or any other document, you may find a smaller change like that. Okay, don't get confused with that. You can define your own way and you can follow this. The overall methodology still remains same. Okay, with the smaller minute changes, the overall idea still remains same. Okay, so same problem somebody else might have solved and they might have got slight difference. Somebody may say that, okay, interquartile range is 4 for them because they got a different number, 6 minus some other number, they got 4. Absolutely fine. Okay, slight differences are valid because the topics are so huge that everybody might come up with their own methods, right, with smaller changes with the original method. Okay, right. So yeah, any doubt?
Sir, I have one more question, sir.
Yes, please.
Sir, that Q1 and Q3, so can you scroll a little bit up?
Yes,
for a second?
Yes, sure.
Sir, if Q1 is 25% and like Q3 is 75%,
Yes.
then their numbers should not be same. It is percentage, right?
Percentage. So sorry. What you are saying, I didn't get.
Sir, I'm talking about the values. Like since so Q1 is 25%, Q2 is 50%, and Q3 is again 25%, right?
No, 75%, right? Q3 is 75, not 25. 25, 50, 75, 100. There are 4 quarters. For first quarter ends at 25, second quarter ends at 50, third quarter ends at 75, fourth one ends at 100. Okay, so if you say the total data set is 100%, divide that into 4 equivalent pieces.
Sir, Q1 is a 25%, Q2 is a 50%,
yeah,
and Q3 is a 75%.
75. Okay, so out of
why
which
you take 25%?
No, interquartile range is what I am trying to teach. IQR has a formula that uses Q1. Okay, that's why I need to stick to the 25 only.
Okay, sir.
The formula of IQR uses Q1 and Q3, where Q1 is 25, Q3 is 75. That's the reason why we are considering exactly those values only, not other values.
Sir,
Okay, sir.
Okay.
Sir, I want to know one thing, sir.
Yes, Manish.
So when we say Q3, okay, got your point, sir.
Understood?
Yes.
Things are clear? Okay.
Yes, sir.
All right. Any other question? No question? Okay. So let's proceed with the calculation. So we have a data set I quickly repeat. Have a data set, right? Increase in, write it in the sorted order, increasing order. I know that I am supposed to calculate Q1 and Q3. Q1 stands for 25%. So 25 by 100 or 0.25 into the length, total length of the data set. So let's quickly calculate the length once again, provided I am not making any mistake. Let's see that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 18, 19, right? So length is 19. So we are fine with that. Right, so length is 19. We calculated Q1, 25 by 100, 4.75. Convert that into the next integer 5, right? And next one, it's so we get a fifth element from the list. I pick the fifth element, 1, 2, 3, 4, 5, which is Q1, right? That is equal to 3. So I'm writing 3 there. The Q3 is what I want to calculate, which is 75%, right? So 75 by 100 into 9, 0.75 into 19 is 14.25. Okay. So there's a question, why can't we take Q2? Q2 is at the middle, right? So IQR does not use the middle one. So specifically we are using Q1, Q3 because IQR equation uses Q1, Q3. All right. Okay. So since our intention is to calculate the IQR is predefined, and that is always Q3 minus Q1. Okay, so only that reason we are using Q3 and Q1s here. So Q3 calculated. So Q3 is 14.25 approximated to 14. You will find other researchers, they are writing that, go to the next number. Yes, you can follow that, right? You will get the 15th number and you can calculate that. So you see, if you go for that, your answer might slightly change. Instead of 6, right? Q3, 7 will become your Q3 if you go to the next number concept. Everywhere I don't go to the previous number, I always go to the next number. That's also possible. Okay, fine. So I calculate IQR, which is Q3 minus Q1. So 6 minus 3 calculated, it's equal to 3. So far, so good. Fantastic. So after this, now I'll go to the calculation of what is called as the lower fence value. Right, from the calculation of Q1, Q3 and IQR, there is a next step to be calculated. So that is called as the lower fence value. Again, this is the standard equation, right? That is lower fence is Q1 minus 1.5 times IQR. Standard equation used in the IQR based outlier detection. So let us use that. So Q1 was 3 minus 1.5 times IQR was 3, correct? So 3 minus 4.5. So this is equal to minus of 1.5. Okay, calculate, keep it ready. Nothing, we don't have to use it now. Simply apply the equation, calculate the lower fence value. Okay, so once you calculate a lower fence value, we need another one, that is upper.
So what is the significance of this value?
Yeah, I'm coming to that. Okay, we'll apply, we'll just calculate it and keep it ready. I'm going to show you how do I use all of them to find the outlier. That's my ultimate goal. Okay, fine. So just calculate this. This is Q3 plus 1.5 times IQ. Okay, people have done research and they say that, okay, this is, if you use these values, it's easy to detect the outlier using the IQR technique. Okay, so let's go for the Q3. I think we have 6 there. 6 plus 1.5 into what was the IQR? IQR was 3, right? So this is equal to 6 plus 4.5. This is 10.5. Okay, so we have Q1, Q3 calculated, IQR calculated, then lower fence value and the upper fence value. They have been calculated with us. That's readily available with us, correct? Okay, now let me write the usage. How do I proceed calculating, identifying the outlier? right? So let me write the lower fence and the upper fence value. So lower fence value to the upper fence value, sorry, yeah, so the upper fence value, that means I got so far it's minus 1.5 till how much? It's 10.5. Okay, so use this, compare this with your data, right? That's how I identify an outlier. If at all the values, whatever values you find in your data set, right, if the values are between these two, right, within this range minus 1.5 till 10.5, right, I don't write a minus here, I'll write 2 so that you don't get confused with them, is it a minus sign or not. So starting from minus 1.5 till 10.5, compare. So this is the lower limit, that's why we call it as a lower fence, and 10.5 is the maximum allowed data, which is not outlier, is 10.5, right? So if the data point is greater than minus 1.5 and lesser than 10.5, then that is not an outlier. So how do you detect an outlier now? This is again specific to a data set, correct? So now I am answering your question. So what is the significance, right? So we are going to detect outlier is equal to, right, data point, right, lesser than minus 1.5 or any data point that is greater than 10.5. Okay, so we are able to identify this. Now let us apply this to the given data set. All right, so let's quickly go back. I'll just copy this. Okay, or I don't want to copy, I can show it here itself. Let's save some time. So number should be lesser than minus 1.5. Do you have any point over here, right, which is lesser than minus 1.5? No. Okay, so yes, I'll repeat, Gaurav, once again, give me some time, right? I'll complete this and I'll repeat everything again. Okay, so see here, any value lesser than minus 1.5, do you have? No. So there is no outlier in on the smaller number side, right? Outlier, if I have a data set, outlier can exist on the left side or on the right side. Right side is bigger number, left side is a smaller number. So when I gave an example, I said that, okay, my temperature is 25, 25, 25. All of a sudden I got a 50. That's an outlier. At the same time, this can be even on the negative side. Temperature might show that all of a sudden it may show that 0 degree, right? On the lower side, which is definitely an outlier, right? So outliers can exist on both sides of your data set whenever you arrange in the ascending order. So first thing is clear, there is no number which is lesser than minus 1.5. So because of that, right, I'm not deleting any, or I am not detecting any outlier on the left side. Let's move to the right side, bigger number. So it says that the largest number that you can have is 10.5, which is not an outlier. Bigger than 10.5 if you have, that is an outlier. So detect the one which is the outlier, right? Which falls under that case is only one number, which is 27, right? This is an outlier, right? Because it satisfies the condition. It is greater than 10.5. I have only one number in this whole series, correct? So because of that, we are calling and we are detecting. Right now we are detecting. Removing is left to us. We just put some if condition and say that, okay, do this, the program will do that job. So removal is not a bigger deal here. So detecting is, right, is what is important. And this is one technique, right, that is called as using interquartile range to do the job. Okay, right? So I'll repeat now everything whatever we have done. So just look at this condition, and the condition is being applied over there. Okay, right. So let me repeat. Whoever has confusion, please ask the question at a later stage. I'll just finish this. So starting from this, I think everybody is fine till the calculation of IQR. So once we calculate the IQR, I'm supposed to find out two parameters. One is the lower fence value and second one is called as the upper fence value. So the equation to calculate the lower fence value is Q1 minus 1.5 times the IQR. Okay, so we calculated that value and it comes to be minus 1.5. And there is another value to be calculated, right? That is called as the upper fence value. So calculation of upper fence value has to be done using this equation. Q3 already calculated. To that, add 1.5 times the IQR. Right. Once we add that, you see we get an answer that is equal to 10.5. Okay. So this is the upper fence value. So fence value means that's the maximum value that can exist, right, in your data set, and that is not a outlier on the upper bigger side, upper fence value. Lower fence value is the same thing on the lower side, right?
Recording stopped.
That particular value is nothing but
Recording in progress.
I think record. Yeah, okay, fine. So lower fence value and upper fence value are the two things, right, which we need to calculate initially. Now you see, I have written the lower fence value and the upper fence value here, right? Anything that, any data point that lie within this range is not an outlier. So how do you detect the outlier? Outside these numbers. So outside in the sense, it should be lesser than minus 1.5, then that is an outlier. Okay, if the data point is greater than 10.5, that is also an outlier. So I got a range, right? What I'm looking for to identify whether a given data point is outlier or not. So that means you can go back and check, right, with your data set. Okay, compare with this. Now you understand that only the number 27 is an outlier because it is above the upper limit, that is 10.5, more than 10.5. That's why this is the upper, it is beyond the upper fence value, so it's an outlier. And in this particular data set, you will not find any value which is below the lower fence value, because lower fence value is what? It is minus, sorry, I forgot the value. How much? Minus 1.5, is it? Yeah, minus 1.5. No value is below minus 1.5, so there is no outlier, right, on the lower side. Okay, so that's how we detect the outliers of a data, right, a series of data, right, using what is called as interquartile range, right? Any doubt?
So if we get a number 10.5, I mean, in the data, so it will be outlier or it will be...
It's not an outlier. It's not an outlier, right?
So it has to be greater than, not equal to.
Yeah, it should be greater than. Okay.
Okay.
If it is equal to, you can consider that as a valid data point only.
Right. Thank you.
Okay, sure.
Sir, I have one question.
Yes, please.
If value is greater than 10.5, suppose true value is there.
Okay.
So which value is then outer?
More than 10.5, you are saying that there are two values which are more than 10.5.
Correct. For example, 12 or 13 is there.
You have 12, 13, 15, 27, etc. You have. All the numbers are outliers. Okay. Any number of points that is greater than 10.5 will be an outlier.
Okay, got
Okay.
it.
Similarly, any number which is lesser than minus 1.5. You may have minus 1.6 there. Okay. Minus 1.6, minus 2, minus 3, minus 100. Everything is an outlier. Okay. You will remove that from your data set. Okay.
Oh.
Yes. Yes. Sure. Any other question? So this is not the only method. We are going to look at another method as well. Right? There are many methods available which are widely used, and many of the researchers have given comment over this method saying that yes, they are very good. Right? We will be looking only at them. Definitely, you can search in the internet and you can find many other methods as well. But definitely, you will observe that this method is widely used. What is called as IQR. Okay, there are directly you can call some functions as well to implement that, but we'll see the coding part slightly later. Okay, so because of this outlier detection using the interquartile range, right? There is what is called as we can perform what is called as a 5-point summary of our data set. Okay, this is very important. I'm going to do the coding of the next part, what I'm going to do now as well. Okay, so using the interquartile range, right, we can visualize the data in a slightly different format. Again, that particular plot we have not seen earlier, but I'm going to show that. It's a part of matplotlib. It's a part of Seaborn. Okay, we have not discussed over there because we didn't have such a data available over there. Now I will show, okay, at a later stage. So this is using the IQR and the related calculation, whatever we have done so far, right? We can visualize, we can get a specific plot over there. But before the plot, let me try to introduce a new concept that is called as a five number summary of the data set, complete data set, whatever I have, right? It is possible to give you some information about my whole data set by using only 5 numbers. What are they? Let me write that here. So before writing that, let me write my data set once again. Okay, whatever I consider, I'll write once again because I need that to calculate one of the parameter which we have not calculated so far. Okay, so that is 1. Maybe I think 1, 2, 2, 2, 3, 3, then 4, 5, 5, 5, 6, 6, 6. I think we had another 6, then 7, 8, 8, 9, and 27. Okay, so this was the data. All right, so let me try to write the 5-point summary of this data set. Right, once you understand that, you can do that for any data set. The first one is called as the minimum value that I have. What is the minimum value you have here? The minimum value I have here is 1. Okay, again, so let me do one more thing here. I have removed my outlier. Don't consider 27. Okay, so I will, yeah, sorry, there was only 1 8 I wrote. 8 8, you see, 8 8 27, 8 8 9 27. Okay, so there were 2, right? Here I wrote only 1 or what? No, I wrote 2, right? Okay, so first thing, remember, in order to give a 5 number summary, always you need to remove the outlier. So I removed the 27. Okay, it might look like I removed 9 as well. So let me remove that once again properly. So I am removing the 27 from my data. So 27 does not exist. Okay, other than that, yes, we have all the other values. Fine. So we are removing this, right? Then I'm doing the I'm picking up some of the numbers. The first one I want is the minimum number. Okay. Then the next value I want totally 5 different points to be picked up. Minimum is the 1. Then go for a Q1, right? In this case, Q1 calculated as 3, right? Then, yeah, somebody give me an answer, right? We already have discussed this. What is the median here? Yeah, please put your answers in the comments, chats.
6.
Okay. Yeah, so 6. People say that it is 6. Others?
No, sir. 6 is more, I think.
Okay, okay. Yeah, look at the definition we had used earlier and please calculate that. Yeah, so we have another answer from Priyankar saying that it is 5. Okay, fine. Others? Yeah, please look at the definition. You can use the definition from internet, find out what is median and apply that to, right, this data and give me an answer. Okay, right? Fine. Yeah. So 5, Gaurav says 5, Ruchi says 5. Good. Let's see. Others? So Pratik says it is 5. Somesh says 5. Yes, okay, that's good. So you need to write something in the ascending order, look for the mid term, right? So that's how you get 5 as answer. Yes, so median in this case is equal to 5. Okay, so the third point is that, right? So definitely we can guess the other points required. So Q3, what's a Q3 here? That's a 6, I guess, right? Okay, and we need the max value. Right, maximum value is 9. So I needed 5 point summary and I got the 5 different points. Why you are calculating only this? I have a reason for that. I'll come to that. So using these, right, let me say that, right, let me draw something here. Okay, so let me say this is the axis starting from the minimum value to the maximum value. Okay, right. So that means let me try to write few of the values. Okay, so I have, maybe I'll start from some negative numbers. Maybe I'll start from -2, then we have 0, then 2, 4, 6, 8, 10, 12, etc. Like this. I have, I'm bringing an axis here, and I'll try to mark these 5 points over there. Okay, so what are the various values I am getting? So one of the value is say 1. Okay, so the 1, let us say it's here. Okay, I'll just mark, right? Then I'll convert this into a graph. So that's 1. I can see that my next number is 3, right? So that is here. Okay, that's 3. Then I can say that the median, that is 5. Okay, that's here. Then I can say that the Q3 is 6 here, and I can see that the maximum value is this 9. Are you okay with the marking of these points? It should be pretty straightforward, very clear. Okay, now you see I'm bringing a new plot called as a box plot, right? That means simply connect them, okay, only the mid one, and you will get a plot like this. When I give a data of this data set, which I have, right, including the 27 I'll show you that this concept later when we do a programming. But now understand that I give this data set, maybe including 27, and I'll call box plot, right? What you get is this red colored chart only, not the horizontal axis, which, right, contains the numbers -2, 0, 2, etc. That will not come. Without that, only the red portion, what you see, right, that is going to come into picture, right? Directly it will be plotted. It will automatically take care of the outlier. It will show the 27. Let me assume that, right? There is a 27 number, right? It will just show a point here saying that that's not a part of your graph, right? Somewhere here, let me assume that corresponds to say 27 horizontal axis. It will simply show a point that, okay, your whole data set has a 27 also in that, but that is an outlier. If at all your data had an outlier even on the left side, let's say -4, -5, there also you get a point indicating that, yes, you have a data point at this value, but again, that is going to be an outlier. So outlier will be automatically identified by the box plot function, right? So, right, that's another way of visualization, right? You can visualize that and clearly you can see that this is how it's going to look like. Yes, please. Yes,
sir,
Rishi.
so you said that this plot will give us the automatically removal of outliers.
Not removal,
But for
detection. It will detect.
detection.
Yes. not remove. It will not remove. If you have 27, 50, etc. in your data set, it will be plotted as a single point. As you can see here in this graph, I have shown 27 one dot, right? Saying that it will be there. It will show the graph. Now, the meaning is that that's an outlier. Whichever is not a part of this graph, right? Red colored portion which we have drawn in the form of a box. If it is not there, that means it is an outlier. So right side and left side, if you see on dots, right, various dots over there, it means it is an outlier. Okay.
Well, and seeing this graph, we can identify our Q1, Q3 median. And
Yes, definitely. So I'm going to write that now. Okay. Yes, that's a valid point. I should have written that already. Yeah. Thanks for reminding. I'll write that. So this means it is a minimum. Okay. In my data set, the minimum valid out of the whole list, the minimum value, which is this. Okay. You can read that, right? And this corresponds to the Q1 value. This is the median. This is corresponds to Q3, and the last value corresponds to the max. Okay. Yes, you can identify them directly from this. Okay. So yes, Gaurav, you still have any doubt? Okay. All right. Fine. So yeah, that's about the outlier detection using the concept called as interquartile range. And there is another concept, that is a box plot, which is actually included in the plotting libraries supported by Python, right? That actually does the same job. It will show you what are the outliers that you have. Okay.
that we have done in pandas, I think.
Sorry, you have done in the pandas? Okay.
Pandas.
Sure.
IQR.
IQR has been done in the
Yes.
pandas, right? Okay,
Yes.
fantastic. Yes. In pandas also will be. Perfect. All right. Do you have any other doubt related to this?
Yes, sir. One question. It is to identify the outlier.
Yeah. Are there any outliers? You can, if you don't want to do the maths, simply you want to visualize, call the function. It will plot
So,
and
but
show
but
you. That's all.
when, sir, one question. We
Yes.
are plotting, but we are removing the outlier first of all. That is the first step. So maximum number otherwise will be 27.
No. See here. This was the procedure I told, how I calculate. But machine will do it automatically. That's what I'm saying. Okay.
Okay.
Right.
Okay.
In order to show you that this is the box plot, I have to remove the outline. Without that, I'm not able to show you. But what machine does, automatically it will calculate what is the IQR. It will remove the outlier and then it will plot that. But after plotting the box, it will also show, okay, there was an outlier 27, here it is. Okay.
Okay.
That's what will be done by the machine.
Right.
All right. Okay. Yes.
So, sir, when we are using this in our visualization, using box plot, so we don't need to arrange them in ascending orders.
Yeah, you don't have. You can simply call it. All right. So again, that is just for the purpose of visualization only, right? It will not remove. Okay. It will show that there are outliers and these are the outliers. It will show just points over there in your graph saying that, okay, there is an outlier, dot, only dots. Okay. But other parts, you will clearly see a box, right? Depending upon what data set we give to the machine. Okay. Yes. Sure. Any other doubt with respect to this? We'll do the coding at a later stage. All right. So we get to see the actual example. Yes. We'll run a code, right? We'll take a data and we'll run it, right? So that's how it is. So interquartile range, anyway, you know that already it's covered in the pandas, right? So you can refer to that. But right. Anyway, I'm going to run the code now itself. All right. Maybe in just few minutes. Right. So any other doubt? If there is no doubt, we'll move further. Okay. All right. So let's shift to the programming part now itself. Okay. So right. So people, if you are ready with the Jupyter notebook, you can also try, right? By yourself, right? Along with me, please try to code. Okay. So we need to practice more to get adjusted to the coding part. So I suggest you to all to code by yourself. I'll not go very fast. I'll also be typing. I'm not a fast. I'm not going to type very fast. I normally type slowly only. So you will be also be in the same pace with me so that you can try. Okay. I'll suggest that. So let's say. So what I'm trying to do here is, okay, I'll give you a heading. This is, sorry, my mistake. Outlier remover. Okay, so let's quickly import. First I need numpy. Okay, import the numpy. Then I want visualization, right? So import matplotlib dot pyplot as plt. Okay, so that's the alias name given, and let me import cborn as SNS. Then I will call matplotlib inline. All right, so let's see. All right, so it runs. Let me define, say, my data set. Data set is equal to, let me use some numbers. Okay, so 11, 10. You can try with the data set which we already have used, or anything's fine. So the one which I'm going to type now, I will paste it in the chat so that you don't have to write this data set. I'm creating some, say, 30-40 numbers, so no need to copy. Once I type this, I will paste it in the chat, okay, so that you can use it. So let's say 10. Okay, then maybe 12, say 14, 12, 15, 14, 13, 15, not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, this is supposed to be a count. All right, then I'll move to the next row and I'll type the next 10 numbers. This is 1, 2, 3, 4, 5, okay, 6, 7, 8, 9, 10. So 10 plus 10, 20 over. Let's go for next number. Let's say 15, 10. Say I'll add a few more numbers, maybe 14, 13. 10. Okay, so this is my data set. Okay, I'll paste it. Okay, so use that as a data, right? And let's since it is defined, let's run that. And now my first objective is right? I'll go for a hist plot data set. All right, let's see. I have to see something, right? So this gives you, right, a histogram plot, right? So maybe it is showing like, okay, between 10 and 20, you have so many numbers. 100 to the 110, you have like that. It is actually showing. Right? All right, so that's the hist plot. Anyway, I just brought it just to see what is happening. Okay, so now let's go for our the procedure which we have followed so far. So I need my data set.
प्लीज रोल डाउन
Sorry.
सर प्लीज थोड़ा सा नीचे करिएगा ऊपर का थैंक यू
Yeah, sure. Okay, so if people are typing, right, please maintain the speed. Okay, so that right, we are all together.
यस
Yes, sure. So we'll move ahead. So next objective is that I need, right, to calculate the interquartile range, right? Anyway, in pandas you already have the function, etc. I'm not going to use a built-in function. I'm going to show how do we do the same concept. How do I code the same concept from scratch? Let me say that I don't know, have any idea about there is a built-in function. Okay, so let's do that first. Okay, so I need to sort, right? There's a function called sorted data set. Okay, so let me let me visualize that whether it's actually happening, right? So let me say data set. Yeah. Okay, so you can see that yes, it's a sorted, right? Data set equal to sorted of the data set. It will be put up into the data set. So I'm printing it out. I'm checking that whether it is ascending order. Yes, I can see that it is in the ascending order. Okay, so everybody is up to here, whoever is doing the program, right? I'll wait for say 5 to 10 seconds so that, right, you will come till here. Okay, meanwhile, any doubt you have, please feel free to ask. Okay.
Is there any command to sort it in descending order?
Yeah, we have. You can sort it in the ascending or descending. So there is a method called, you have to specify, right? Do you want to go for a ascending or descending? Okay, so you can check that, right? Anyway, if you get a doubt, means you can actually check this, right? So you see, reverse equal to false, right? Says that it is ascending. If you say true, it will reverse. Okay. So use the help like this whenever you get a doubt. You can use this help, which is going to give you the most common doubts, whichever we get right, will get solved there itself. Okay. Yes. All right. So data set till here, I think everybody should be there now. So calculate the percentile. I think we have discussed this when we were discussing some topic. I remember, right? Okay. Let's go for that. Okay. So yes.
So when we have given the command sorted, so it is arranged everything in ascending order, right? The whole data set.
Yes. It's in the ascending order. All right. So default sorted will give you the ascending order, right? Okay. Now I want to calculate the Q1 and the Q3, right? So the name given itself, I'm using the same thing here so that you don't get confused when you see this code at a later stage, right? So there is inside the numpy, I have a function called percentile. All right. So that actually calculates, right, from the data set. From the data set, I am asking, use this data set and give me the following percentiles, right? From the data set, any percentile you can calculate, because Q1, Q3 specifically are 25th and the 75th percentile. Okay, but you can actually calculate, I may want 40th percentile, 40. I may want 60th, right? If they build a function which actually does a specific numbers only, then that function is not useful, right? So they have built the percentile function under the numpy in such a way that you can use this for calculation of any percentile you want. That this is how you feed it. You will say that I want 25 and I want 75. Right? So that means I am supposed to get, so it calculates. Let me print, let me check. Oh, sorry, my mistake. Right. So this is, let me write a Q1. You see Q1 comes to be 12. Let me write Q3, that is 15. In this data, Q1 is that, Q3 is this. Okay, fine, so far good. Now let me go to the IQR. So IQR is nothing but it's Q3 minus Q1. Okay, anyway, it's not printing. Let me check. That is 3. Obvious, right? 15 minus 12. Now, right, what's the next thing we need to calculate in order to detect the outlier using this IQR technique, right? It is the lower fence value and the upper fence value, isn't it? Yes. So, LFV, right, is equal to, I'll write small letters. Normally, we use the small letters, that's why. It's just a convention, you can use bigger also. So, Q1 minus 1.5 times the IQ. Okay, so LFB. So LFB is calculated 7.5. Upper fence value is equal to Q3 plus 1.5 times the IQ, and print that. Let's just check. $19.5. Okay, so simply we are writing the code for whatever we discussed when we try to understand the theory behind this, right, whole concept, right? I'm straightforwardly writing the code for that. Okay. All right, so let me show you the plot which I was talking about, right? So let me go to that first. It's in the CBOR. Okay, so I'm using SNS dot. The box plot is a command. Okay. See, in this case, right? Okay, I think I have not detected the outliers. I am supposed to do the outlier. I'll show you that. So how many outliers are there in this particular data set? 3, right? And they are more than 100. Okay, whichever 3 numbers you have in your data set which are more than 100, yes. And you see the box plotted in the same way which we discussed, right? Only thing is that color is changed, absolutely fine. So the lowest value you can see, the first line what you see, right? So I'll show that. So this line corresponds to the minimum. Similarly, this line corresponds to the maximum in the data set. So the Q1 is this, the first line which you see in the box. The mid line, there is a central line there that corresponds to the median value, and another straight line which is the right side boundary of the box is the Q3. So as we already have seen, that Q1 and Q3 are very close. Because of that, you see the width of this box very small. Okay, right? So test with any other data set which you want. Definitely, this might enlarge as well. Okay. All right. So I hope this is what we
Hi, sir.
now you see. Identify that there are 3 outliers. Okay. So not necessary to know that what are the outliers. Simply remove the outliers. How to do that? We'll show you now. Yes, I think we have a question. Yes.
Sir, Q1 and Q2 and Q3. Q2 is also a median line, and mean and mode. Q1 and Q3 is the mean and mode. Okay.
Yeah, so I'll repeat. Yes, what you are telling is right. So there is a minimum value that is present over this line. Okay, the first line.
Okay.
Last line is the highest value. Okay, maximum.
Okay.
So there is a box like this, and the box has 3 parts: the first line, mid line, and the last line. The first line of the box is Q1. Last line, that is towards the right side, whatever you find, that is the Q3, and the central one is the median. Okay.
Okay.
Yes. Yes. Any other doubt?
Sir, please show the code. My net is disconnected, so I
No problem. I will show you the code. Okay. So
was this
Yes.
only Q.
yeah. Okay. Those who are coding with me,
Yes.
I'll give say 30 seconds of time so that you can just copy this code, run it on your side, and right. Meanwhile, if there is any other doubt, yes, I'll answer that as well. Okay.
Thank you, sir.
Any other doubt?
No, sir.
Okay. So you say we can use a box plot just to identify, right, the 5-point summary plus the outlier. Majorly, this is used. We will not be able to identify what is Q1, etc. from the graph itself. So we don't use it for this, but the concept behind the box plot is 5-point summary. That's what I wanted to show you. Plus, there is a graph technique called as a box plot, which directly shows you if there are outliers, it will show you that as well. Okay, so we have so far calculated the IQR values. We have the upper fence and the lower fence. Okay, now we will use that to identify the outliers. Okay, I want to see the outliers in this graph. It will say that okay, it is more than 100, something like that. I'll come to know, but I am not able to see that. I want to see the values, means what you can do. I will show you. Okay, yeah. Any other question? I think no question. All right, let's proceed further. Now, let me say I want to detect the outliers. All right, so outliers equal to, you can try any method that you are comfortable with, right? Most people prefer the if condition. If the data is in my data, if a value is lesser than this or greater than this, put it into the outlier, right? Make that as an outlier, right? That's very much valid, okay? And that's the right thing to do. But Python, there is a support. You don't have to go for a for loop and keep on checking each and every number present in your data set, right? So there is what is called as a list comprehension, right? So I will use that because that's what I'm comfortable with, right? Any other method you are comfortable, please go ahead. Okay, so write the code by yourself and let's compare the results at a later stage. Okay, so what I do, it's X for X in data set. In the data set, every element, X for X means every element in the data set, right? If, let me put a condition that X, whichever I'm considering, should be lesser than, what's the name given? Lower fence value, upper fence value. Okay, it should be lesser than lower fence value, or X should be greater than the upper fence value. Okay, so you don't have to write many lines of code. Python supports you very well. With minimum number of lines of code written, it will get the things done. All right, let's check whether this is going to work. Okay, so I'll type outliers. So it says 102, 107, and 108. Okay, any doubt? So we can see the outliers in this fashion, right? Removing the outlier will give it as a homework to you, right? You know the outliers now. Do something with this line of the code, right? Something you need to do there itself so that outliers get eliminated, and you get the remaining values, right? The remaining points of the data, right, will be retained in the data set. Okay, do something here. Okay, not a big change, very minute change. Only one thing you need to change so that, right, everything will, right, outliers will be removed and remaining terms will be kept, right, over there. Okay, so that change that name as well. Okay, don't keep it as outlier because that's not outlier, that's the valid data. Okay, so that part is a homework. All right, so very simple things. Okay, any other doubt? No doubt. Fine. So let's go for another method, right? So I did not discuss the other method when we discussed the theory part because we already have discussed 50% of that, more than 50% of that when we were discussing about the standard normal distribution. So I'm going to use the standard normal distribution and its property to remove the outlier. Okay, right. So let's do something now. I'll paste a photo. Okay, so that yeah, see this. So there was a question like why you consider only the value as 3, right? Why not there are no values more than 3? A question came. I tried to answer in a simplest way yesterday, but I'm going to give you a big picture now. Okay, so consider this. This is the, can you see that? Can you identify this is standard normal? Centered at 1. I'm not able to visualize the the sigma value, right? Sigma being 1, I am not able to identify because visually it's not, we will never be able to identify. Okay, when you use the calculation mathematics, when you apply the mathematics and calculate the value, it comes as sigma equal to 1. But if you have any data, any standard curve, and you are converting, sorry, any normal curve, and you convert that into the standard normal curve, what you are going to do, you know, you have an equation, you can convert. Now we'll use some property of that, right, over here to find out an outlier. Well, we'll see, we'll compare. Already we have one method, right, which is the IQR that works fantastically, right, on any data set. Not a simple data set like this. Go for very complicated data, still it will work. Okay, you can refer the various materials available in the internet because people will write in their documentation, right, saying that okay, this is how I applied a method and this is the result, etc. When you read it, you will understand that yes, IQR is good. But I want to justify that IQR, whatever is performed by IQR, is correct. If you want to see that, you have to apply any other method and you compare the result so that you will come to know that yes, this is what is happening. That's our idea now. So consider this, right? This is the curve, standard, normal distribution, right? So when you see on the horizontal axis, instead of writing what is called as the x value or the z value, we are writing the standard deviation because the marked values like 1, 2, 3 are there, right? They are the standard deviations. In the sense, at the center it is 0, which is the mean, right? 1 means it is let me write something. So the 1 which is written here, right, it is mean mu plus sigma. Okay, it's 1 is written, but it is 1 times sigma. Okay, this is 2 times sigma, 2 sigma, right? 0, sigma, 2 sigma, 3 sigma. So 3 sigma will come here. Okay, so similarly on the other side, mean 0 minus sigma, minus 2 sigma, and so on, minus 3 sigma, and so on. Okay, so concentrate on what is written below this, right? So this is another perception of the same normal distribution which we have been using in the previous session. So there we never look at what percentage of your data set exists over there. But now you see, I'm trying to give a clear answer to the yesterday's question, right? 34% on the left side, 34% on the right side whenever you have a standard deviation of 1. 1 means 1 to the right, 1 to the left. That means out of your complete data set, 64%, sorry, 68%. 68% is covered. So it's there within 1 sigma right, 1 sigma left, right? So many 68% of, if you have 100 points on your data set, 68 points will come within this. Okay, hope it is clear. Then let's expand to the -2 sigma and the +2 sigma. In the sense, I am actually trying to find out the area between this region, right? That actually covers 95%. Out of 100 data points, 95 points will come within this. Almost you are covering your entire data set within the 2. Go beyond that, consider 3. Right, the third one adds a very little portion on the left, same thing on the right, right? So that adds another 2.1%, making this as 99.7% of the data, right? Which means 99.7, let me make it approximate to 98, because out of my 900 data points, 98 are already covered. That is more than sufficient. 2 may be the outliers, who knows, correct? So you see, if I use the 3 sigma, right, that's the 3 which we were looking over there, right? So we consider till there because of the same reason. That entirely covers 99.7% of the entire, right, data points, right? So which can be interpreted, because there we are calculating in the Z score, whichever we calculated, right? From X you calculated a Z, which is called as a Z score. And in that Z score, it's the area under the curve, which we are talking about. So if you consider up to that 0.3, right, from 0 to 3, which actually refers to the 0 to -3 again, because both area remain same, right? Symmetric property. That covers 99.7% of your total area under the curve. More than sufficient, right? So because of, that's the one reason which I'm talking about. Okay, that's the reason why, right, we are going to consider only till there, that there's a specific range in that, right? So that covers almost everything. Okay, so now we have a question. How do we apply this logic, right? I'm covering 99% of this, right? I'm able to cover the 99.7% of all the points within the from the 0 to 3 sigma to the right, 0 to -3 sigma, right? That is on the left side. How do I apply, right? I want to say that if it is beyond this point, if any point lies on the curve which is beyond the -3 sigma or +3 sigma, I'm going to call it as let me try to build a logic like that. Okay, I hope the point is clear. If you have any doubt, please feel free to ask now itself, right? I'm trying to build a logic. My logic is, I have a plot. I know 0 is the center. There is a sigma, minus sigma, plus sigma. I consider 3 sigma to the right, 3 sigma to the left. Every point that is covered, right, in my distribution are valid points. In the distribution or in my data set, if there is a point which is beyond this, right, more than 3 sigma or less than 3 sigma, I am going to call that as an outlier. Okay, so there's a question saying that this is for any length of the data. Yes, right, this has to be valid for any length of the data. Length doesn't matter, right? Out of the total length, right? Now you see we are not plotting the length of the data. There may be two repeated so many times, right? So it will come on the same point, because 2 is within, maybe if it is 0, 2 may be well within the sigma itself, right? So it will come below 1 itself. The same point will come over there. So length does not matter. Okay. All right. Yeah. So any other question? So our overall idea is this, right? So now our intention is that I want to implement this on the coding part, right? So there is no mathematics. I'm not going to do any maths here, right? So I simply want to take a data set. Let's say the data set is already available with us. Okay, we have the data set already available with us, and from that data set, right, I want to find out the outliers. My logic is I will find the mean, I will find the variance, any point which is outside the three sigma, right, on the right or on the left side will be an outlier. So this is my logic. Okay, so let's do something. Let's take it as a assignment to do now itself. So anyway, we'll be going for a break in a while. So take this as an assignment to do now itself. No submission, right? Just an assignment. Just a practice session. All right. So try your own. Right. You don't have to use any of the built-in functions, I guess. Okay. No need of using any built-in function. Very basic part of the code will work here. Okay. Right. So try that. So 5:27 in my watch. So maybe 15 minutes break plus 5 minutes for this whole thing. All right. So let's meet back at 5:50. Okay. So that we'll discuss the answer of this. Okay. Any doubt? Any doubt before that? Anything to be clear?
So what can you please repeat again what we need to do as part of the assignment?
Yeah. So you need to write a code for the following, right? I have a data set already. I pasted the data set, right? Let's use the same data set. Okay. And in that, right, you are supposed to find out, right, which is a mean value. And from the mean, if a value lies to the right side beyond the point which marks 3 sigma, that is an outlier. Okay. At the same time, if a point lies on the left side which is lesser than the -3 sigma, that is also an outlier. Okay. So you just have to either print the outliers. I think that is easier. Print the outliers is my question. Okay. On that same, already you have an answer, right? What are the outliers? You know the outliers are 102, 107, 108. So, but don't use that logic which already has been done using the IQR. Use this logic. Okay. So use this kind of, don't go for a graph and all. No need to do that. Okay. Because assume that this is already in the normal distribution. Assume. Okay. We'll see. Right now we don't have to find out what distribution it is. But the normal logic is that from the mean, 3 sigma to the right is a valid region. Beyond that is an outlier. Similarly, from the center, go to the left. 3 sigma up to the 3 sigma is valid. Beyond the 3 sigma is an outlier. So just try to write a code to do that. Hardly 4, 5, maximum 6 lines of code, I guess. Maybe 1 or 2 lines here. Okay. So this is what is expected. I think I try to give a clear picture. If there are any doubt, yeah, please go ahead. Otherwise, we'll take a break, then plus 5 more minutes for doing this job. 5 to 10 minutes you can take, doesn't matter. You have to apply your logic, right? Then we'll discuss the answer. We were discussing about the outlier detection, okay, identifying and the removal. And one of the method, that is IQR, already we have completed, and we are continuing with an alternative approach so that we can identify and remove the outliers using the normal distribution, right? Assuming that the data set is normally distributed, 99.7% of the data will lie within 3 sigma, right? Values, right? From the center, 3 sigma to the right, 3 sigma to the left. Okay, so we were considering the same data set as earlier. Okay, and the assignment was to detect the outliers. All right, yeah. So we have Pratik and Ruchi saying that they have already completed. Yes, that's good. Very well. How about others? Still doing or halfway through? What's the status? Maybe I can give maybe 2-3 minutes of time more if people are still working on that. Okay. Right. So let's do something. I will start typing the code. All right. So meanwhile, right, If anybody has a different approach than what I'm using now, right? Again, I'll give a chance for you to share your screen and discuss your approach as well. Okay, afterwards. So let me try to write my view on this. Okay, so let me start with defining. I'll use a function. Okay, so I'll go for a function, right? I'll call it as detect outliers, and I'll pass some data to this, right? And let me create a list. It's empty list. As of now, I don't have any data here. So I'm going to call it as, I'll create that, but I'll keep it empty, right? Then, right, so I'm looking for the 3 sigma value, right? So the 3 is what I'm going to use it as a threshold. To that threshold, I'll multiply by the sigma value. So let me define. It's not mandatory. You can use 3 whenever required, but right, let me use it. Threshold is the 3, right? Because 3 into sigma yet to be calculated, so I'm not able to consider that at the given point of time. But let me calculate mean value. Mean value is the central value. Again, in this diagram, I have shown that we are considering a standard normal distribution. But even if I'm assuming that it's not a standard normal distribution, still there is some mean. From the mean 3 sigma to the right, from the mean 3 sigma to the left. That's what I'm supposed to consider, because I cannot say that what already exists, right, is the normally distributed data, standard normalized distribution. I cannot say that it's already there, right? Normally it will not be there. We need to convert if required. But as of now, our intention is not to do that, right? Okay, so, all right, let me write it this way. So mean is equal to NP mean of whatever data I pass to this function. I'll take the mean like this. Then standard deviation is equal to NP dot std of this is the sigma. Okay, so let me call this as sigma itself. All right, so that becomes easy. Sigma equal to this. Okay, now I will go for a loop, right? So for every each and every data point, I have to do something, right? Say for in the data set, I'll check a condition if, right? See, the idea is that I want to consider the negative point as well as the positive points, right, from the central one. So whenever you subtract, you move to the left side, you make it a negative value. So what you can do, you can take a magnitude of that, right? The concept magnitude we already have used in one of the problems, right, when we were solving normal distribution related problems in the previous class, right? So there we have used that. So I'm going to use it. It actually, the magnitude can be considered as a absolute value which is present in the numpy. Okay, so np dot abs, absolute value of that value in the sense the z value which we calculate. How do you calculate a z value? That is I minus the mean divided by the sigma value, right? If it is greater than threshold, you can do that, right? So absolute value of, let me write it in this way. So I is my variable, I minus the mean value, that is a mu value, okay, divide by the sigma. Okay, if this is greater than the 3, you can write this, but what we discussed was slightly different. Remove the sigma, multiply by sigma to this side, threshold into sigma, that's also fine. Okay, so because threshold is 3 sigma is what I was looking at, right? If at all it is greater than this, then that will be an outlier. Okay, so apply the logic accordingly. If this is if this particular concept you find it difficult, right, take it to the right sigma to the other side. All right, so there is a question, what is absolute? Absolute is a magnitude, right? Because I want to move to the right side or to the left side, right? But I'm looking for 3 sigma only, right? On the left side I'm using minus 3 sigma, right side I'm using plus 3 sigma. Magnitude means it is 3 sigma irrespective of where you are moving, right? Right side or left side, if at all the magnitude taken is more than 3 sigma, that is an outlier. Okay, so that's why absolute is being used. So if this is the condition, right, simply put it into the outlier. So can I call it as outliers? I think we call it as outliers. Yes, outliers dot, can I use append? Yeah, append is supported of I. Okay, I will be appended at the end of the existing list. Since the list is empty, first value will go to the first position, second value go to the second position, and so on. Okay, so that will be done, and after that I am supposed to return, because I am inside the function. So return, you can return a list, return outliers. Okay, so let me try to run this part. Yeah, this runs without any error, but let me see if there may be an error coming up when we run. So I'll call the function detect outliers of pass the data set. I think we have the same name given earlier, right? So the data set, yeah, data set. Okay, I'll pass that. Yeah, okay, right. Any doubt with the coding or anything to do with the logic? Yeah, please go ahead.
This can be done without using the function.
Yes, definitely. So why I use the function? Because normally the Pythonic way of programming is it's a modular. You try to write modules for doing every job. It is expected to write something like a function. Okay, so detecting outliers is a job, right? To do that, you can write a module for. Okay, so that's the reason why I'm writing this way, not mandatory. Okay, yes. Without the function, directly you can operate on the data set directly, and you can get the things done. All right. Yeah. Anybody else?
Yeah. Sir, I have this question related to like why we are using for loop.
Okay, so for loop is being used here. So one option I already showed you, right? That is the list comprehension. I can use this itself. Okay, the list comprehension I can use. I want to show you the other option as well. That's why I used the for loop here. That's the one thing, first part. Second part is that the logic is that I know that if a point in my data set is outside something, it is an outlier. So how do you check that? Each and every point you need to consider, correct? So that's what is happening here for I in the data set. In the data set, every point, that is I. Okay, do something. So you see, for I in the data set, for every element in the data set, if a condition is satisfied, that particular I is the outlier. So you see that. So for loop is being used here. It's the condition that, okay, from here to here, every element in the data set. If at all this condition is satisfied, then you see, put it into the outlier. That's all. I'm trying to find out the outlier. So the condition is what is important here. So I minus mean, x minus mu divided by sigma should be more than 3 sigma. So sigma is already in the denominator, so I'm not using the sigma here. You see, I'm simply using the threshold. Threshold is 3. Right? If you are confusing, don't use the variable threshold. Simply write the 3 here. Okay, simply replace this threshold by 3 there, because x minus mean, right, divided by sigma should be greater than 3, or x minus mean should be greater than 3 sigma. Anything you are comfortable, you can. Okay.
Excuse me, Excuse me, sir.
Yes.
We have an image where you were explaining all about all these things. How to get that image? I could not get it.
Which image? This one?
That's the yes.
This one?
Yes, yes.
No, it's actually, I have pasted from some. Okay, you will not get this, right? So in the material which I am going to share you, this will come. Okay, you will not be able to get this by doing a code. Okay,
right.
I added a text box, and in the text box I have pasted the image. Right, it's not a part of code. Okay, so you see here, these are the coding cells. But if you see, when I click here, it is not a coding cell. See, the color changes. Right, this is a text box.
Okay.
All right.
Right.
Yes.
Thank you.
Sure.
Yeah, so hello, Pratik this side. So I have also completed this, but for me, I have directly, as you told, 3 times the sigma. So I have considered the for loop and the variable which I am using to iterate to the for loop. So basically, I am directly comparing its value with the standard deviation multiplied by 3 times. So when we do np dot standard deviation, you get the standard deviation value. And when we multiply it by 3 and minus 3, so it will consider both the side, left side as well as right side, and then the outliers will be
I think you will be getting, you have a sigma, so multiply by 3 to get a 3 sigma and minus 3 sigma, I guess, right?
Right. That is the way I have used it.
Yeah, absolutely fine. Please go ahead, share your screen. Okay, let me do one thing. I'll stop sharing my screen. Okay, and I will allow you to share the screen.
So I have done in the same manner.
Yeah. I'll give a chance for you to. Okay.
I think so. It is showing visible. Let me try.
I have enabled right now.
Yeah, yeah.
Please go.
Yeah. So let me know if you're able to see my screen.
Yes, we can see the screen.
Yeah.
Right.
So basically, in NumPy we have an option of taking the mean. So I have taken the mean.
Okay.
I have taken the standard deviation. Then I have taken the empty list for outliers where I will get the outliers. Then I have used the for loop, and then I have tried to check the left hand side and right hand side by multiplying 3 times the standard deviation. Okay. And then I have just appended the value, and when I printed the value, so I got the outliers.
Yes, perfect. Right.
And in the second assignment also I have tried without getting the data set without outliers. So I have just put this condition.
Okay.
You told one condition change.
Yes. Just
so
change something,
working.
You will get that. Right?
Yeah, so it is coming fine. It is still 90.
You are getting the same thing, right?
Yeah.
Perfect.
Right.
Yeah.
Thank you.
Okay. Thank you, Pradeep, for sharing this. Anybody else who wants to share their screen and discuss their
Yes, sir,
approach?
I'm sharing. Sir.
Yeah, please go ahead, Ruchi.
So my screen is visible?
Yes, we can see the screen.
So first of all, I have calculated the sigma using this np.std dataset.
Okay.
Then from that, I am taking the 3 of this sigma, and this is around 79 plus minus 79, and then I am using this for loop. X should be less than minus outlier, and X should be greater than n, and then I calculated this.
Perfect. Yes. Another approach. Yes, I appreciate. Yes, that's good. Both of you have done good job. Thank you. Anybody else? Okay, let me share my screen again. All right. So I hope everybody is trying from their side, and yeah. So if you apply the logic, yes, right, irrespective of the way you code, you will get the answer. Okay, that's the ultimate thing we come to know from this. Okay, so it's detected now. Anyway, apply a logic so that you can remove
the function you are defining. So what is this outlier dot append I?
So outlier is actually an empty empty list, right?
Okay.
So to add a single element to that, you can use a function called append. Okay. So if at all, right, this condition is satisfied, I know that I is a outlier. So I am saying that if that condition is satisfied, append this I to the outliers I create. Okay.
Okay. Thanks.
Yes. So normal way, what is preferred in the Pythonic coding technique, and whenever you go for the higher level concepts, maybe in the machine learning, right, then deep learning, etc., it is suggested that you try to write if you have some job in mind, like identifying even or odd, finding a square root, and etc., right? So what is suggested is that you write a specific function for that, even if it may be very small thing like squaring, right? I have a function, I want to take a square, right? It is suggested that you go for a simple function. So define def square of x, return x into x, that's all, right? This is what is expected. That's the Pythonic way of writing the code. It is easy to track when you have 1,000 lines of code and there is an error where it is coming from, right? It is easy to track. Every time I don't prefer writing x into x to square, right? I prefer calling the function square of that, so that you can, right? In squares you don't get any errors, right? But right, whenever a part of the code is being repeated again and again, instead of writing, right, something like that, it is preferred to write a function. Okay, so functional blocks are expected, right? In Python for sure. Other languages, it's left to the code, the writer, whoever is writing the code. Okay, right. So even if it is a simple task, it is suggested to go for a function. Okay, all right. Again, it's not mandatory. Let's proceed further. Now, let's look at the concept wherein how to solve the problems we were solving in the previous classes using the coding technique. I want to write a code to solve the problem. What is the chance that the number of students are more than this, number of students scoring 100 is less than this, like that? We want to solve those kind of problems. Mathematically, we all are very familiar now, right? We know that how, if I give a problem, how to solve that manually, right? So that was the first reason. If I directly jump into the programming way, nobody will understand what is happening, what value we are calculating, etc. We will not be knowing that. So since we already have done the mathematics already, right, this becomes easy for you to understand now. Okay, so my first job is to say, okay, so let's do something. Let's try to create a distribution for a specific case. All right, right. Let me give you a question. All right, let me try to form a question for you. Right, so this is a question, right? So we have a data of heights of adults in a town, and the data follows normal distribution. Okay, so mean is 5.3 and standard deviation is 1. Okay, I want to create the normal curve first. Okay, that's my fundamental idea. Let's see. So okay, I need to import something more. I already have a NumPy, I have Seaborn, I have the matplotlib with us. Already we have brought that into the memory. Okay, we have imported. Now I'll go for another module, that is from scipy dot. Already we have used this once when we were trying to get the graphs of various types of the distributions. Okay, try to recall. It's called as a scipy, scientific Python. Inside that there is another sub module called as a stats, which deals with the statistics. Okay, from that I want to import the norm. It means I'm bringing the normal distribution and related calculations into the memory. Okay, so that's what is going to happen now. Right, so I need the x-axis first to be created. So let me go for call that as a data point. So data is equal to np dot range. Okay, np uses a range. Okay, in 1 to 10 with the increment of 0.01. Okay, and see, the x variable is created. I'm going to create a y value, that is phi of x, that is the PDF. Okay, so I'll call that as the probability density function. So PDF is equal to norm, already it is there in the memory. I can use it. Norm.pdf says create the normal PDF. I need to say what are my x values. What are the x values? X values are called as the data. It's the horizontal axis. Right? If you are confusing, I'll change this to x. Okay, so I don't want you to think that that's my y value. Okay, so I'll change this. This is x. X value should be given. Then should specify. There are two more requirements to be given here. I have to tell that what is the mean value. Right? Mean value is identified. So if I'm using the scipy.stats, right, it identifies mean as a variable called LOC, location, where the graph should be located somewhere, right, on my axis. Where is that location? That is the mean. So in the question you can see that equals to 5.3. All right. Then it also says sigma, standard deviation is 1. To identify the standard deviation of the sigma, you should mention scale. Okay, it has to be scale. I cannot say that it's a sigma. Machine does not understand. The scipy has been written in that way. So scale in the sense the sigma value, and the location indicates the mean value of whatever you are expecting. Okay, so let's create this. I'll run this. Oh, sorry, my mistake. Sorry, that is 10, right? Mistake. Okay. So see this, right? It is created. I'm not able to visualize because I didn't ask it to plot. Let's go for the plot. I think I already called the keyboard. I'll use that. SNS dot. I'll go for a line plot. Plot the X value. Plot the Y value as a PDF. Okay, let's see whether this plots something or not. Then I'll make the modifications. Yeah. Okay. So what I do, I'll try to make some small modifications, right? I will set something. So set the style. Okay. Let me check. Yeah, set style is there. I will go for a grid. This is one of the famous with grids it will come. So I remember that still. It's white. It's a white grid. Let me check whether I can get. Yes, I can get this. Right. In addition to this, you can always go for let's say the X label, Y label, obviously, right? So you can use that if required, or I can also change the colors, right? Anyway, you know the options, right? Let's not go to that. So things to remember, things to understand here is the creation of the data set, right? The PDF, you can create that by using norm.pdf, right? This is the important function which you need to remember. You also have to remember that this is present inside the scipy.stats, right? In the form of NORM. So once norm is available, directly I can write this. Okay, that's fine. And what else we can do? Yeah, remember that this variable, this name you need to remember. Mean is actually identified as LOC, location. Scale is the one which actually identifies, right, the standard deviation. Okay, if you change this location to 0, you will see that that gets shifted to the center. All right. So anyway, so I'll go to that at a later stage. As of now, my intention was to answer this question, whatever we have given there. So it says the mean is a particular point and the standard deviation is like that. Okay. Right. Now, I hope things are clear. Any doubt? Is there? Yeah.
How we can interpret this diagram, this PDF function?
Yeah. Okay. I'll answer that. Yes, sure. So the PDF is something like, it says that the mean value, we can only identify the mean value from. Okay. So central value, if you try to see, it comes somewhere, right? I'll try to show Okay, let me take up a color so that I can show you. Okay, so just look at this. So from here, if I try to consider, it comes somewhere around 5.3. That's one thing which we can see clearly. So the sigma value, whatever is given, right, from the graph, we may not be able to, okay, identify that. But one more thing is that let's consider something like this graph. It says that, right, somewhere wherever you think that, right, I have 68% of the data. Again, the 68% is not clearly visible when I come to this graph, right? If at all, if it is possible to make an analysis, right? So if this is my central value, and if I say maybe majority of them comes over here, right? If I say 5.3 here, right? So that will be considered as the sigma and minus sigma. Again, sigma is not visible on along the horizontal axis. I have, right, a specific sigma is not visible. What is plotted on the x-axis is the x values itself. Okay. Yes. So what we can understand is only the mean value can be seen direct. Other than that, nothing. Okay. Any other doubt?
Value is already given in the question itself. So how? What other things we can interpret from this diagram?
Nothing. You cannot interpret anything else because we don't have a data set, right? Data set is being created now. So the question says,
data set is that we are having this X range. That is our data set, no?
Yeah, X is only that data set. Between 0 and 10, we are creating a this thing, PDF.
We can talk about probability density rate function. So from the diagram, we can say like that the major, so near mean, there is the probability of we having more data set.
Obviously, that's correct, right? That's what is the distribution, right? So anyway, those things are already been discussed, right? So I'm not adding that point again, right? Other than that, we cannot interpret anything. So already we know that there is mean, where is highest occurrence of probability, right? Probability is highest. You can see that, right? So surrounding to that, you have, right, the points which can be repeated, right? That's all there. As you move away from the center, it reduces. Yes, that's why the shape comes like that. All right. Anything else? Okay, right. So anyway, we just have created that. Now we'll move ahead and I'll put another question. Let's say, right? Let's say, okay, let me. Right, pick one person randomly from distribution. Now you see, what is this distribution? It is corresponding to the height, right? It's a height, average height is 5.3. Just read the previous question again, right? Whatever distribution we have here is corresponding to the heights of adults in a town. So mean value of the height, what you find in the city is 5.3. Right? So that's what is being seen here. So height less than, say, 4 feet, right? You see the chance is less. As you still reduce the height, it becomes lesser. Even on the right side, it keeps on reducing, right? Okay, so central value has a highest chance. Now the question is, right, if at all you pick up one person at random, right, what is the probability that, right, the height will be lesser than 4.5? Right? What do you expect? What should be done if this is the given question? If I give this question yesterday, right, you know the procedure. Correct. Now my intention is that I want to do maybe let me go back to the diagram. So maybe 4.5 comes somewhere here, I guess. Maybe approximately. Okay. So what you are supposed to calculate is the height, is actually this area, right? Area before this, isn't it? Are you okay with that? This is what I want. Right? Yesterday we had the table with us, right? You could have converted this into the standard normal, right? X minus mu by sigma, you do that, you know the procedure, right? So get a value, right? And you will be able to do that. But now I don't have a Z table available with me, right? So you are able to recall what we used to do earlier? Okay.
Yes, sir.
Yes. So now let's look at the answer, right? So you know now what I'm supposed to do, right? So overall, now the idea is this. One approach we used in when we try to solve manually was that since we don't have the standard, sorry, the normal table, which is this table. For this also you can write a table, but that is very difficult because your distribution may be present anyway, right? Right now it is located around 5.3. I may change the question, it may change to 6, it may change to 3, etc. Now for every cases you cannot keep creating a table. That's why there for a manual calculation, what we were provided with was a standard table, irrespective of whatever is your curve, right? Normal curve, convert that into standard curve and do solve. That's the only option we have, right? If you don't want to do the integration, right? Other option, yes, definitely integration. Now you see, this whole curve is itself is the phi of x. I want to simply calculate the area under this curve. Means if you want to go for integration, yes, you can integrate from minus infinity, okay, till this point, which is 4.3. So integrate minus infinity to 4.3. This particular phi of x will give you the answer, right? Mathematically speaking, this is what I am supposed to do now. Agreed? Right, but I'm not going to do the integration. I'm not asking the computer also to do the integration because there is a much easier way, right? The easier way is called as cumulative density function, right? Cumulative density function is nothing but at every point, whatever is plotted over there is the area before that point. In a sense, if I say find the CDF of the mean value, it will say 0.5 because previous to that you have 0.5, total area is 0.5, right? And similarly, if I ask what is the CDF at infinity, right, somewhere here I may have infinity, it gives 1 because total area before that, right, is 1, right? So understand what is CDF, because CDF is a built-in function. I can use it directly. I don't have to ask machine to do integration, no manual calculation, no table, nothing, straightforward. Okay, so CDF, cumulative density function. Okay, so we'll use it, right? So let's go for this. So this is the answer, very simple. Norm of, say that, okay, I just have to mention this. Okay, so location is equal to, which is the mean, right? So 5.3, and you have to mention what is the scale, right? So that is equal to 1 dot, I think we have a CDF directly available. Okay, let me check. Yeah, you see CDF is available. I typed C and I pressed tab. It gives it, if there are multiple options available, it will show everything. What are the functions starting from C you have? Okay, CDF just mention till where. Okay, so the question says till 4.5. Always it is from the leftmost point till that point. You don't have to tell infinity. I think it was not 4.3, right? It was 4.5. Sorry, I was explaining with 4.3, I guess. Please correct that. It's 4.5. So simply write 4.5. Right? Multiply by 100 to get a percentage. So what is the probability that, right? Somewhere here. Okay, so maybe 4.5 comes, right, this value, 4 point something. Okay, so that's the one part of the question. All right, now say, okay, let me change the question.
Sir,
yeah,
what is the CDF? I am not understanding.
CDF calculates the area under the curve until that point. Okay, whichever point we are considering, until that point, all the way from infinity, because that's what is my question here. The question says that what is the chance, right? Until 4.5, I want to calculate the area before this, isn't it?
Yes, sir.
So
Yes.
that means I can use the CDF and I can call the function.
So it is from minus infinity to or plus infinity?
Minus infinity to that point.
Minus.
Always the leftmost side till that point. Okay? Yes. Okay. I'll give you another question. Please try to solve. Very similar approach. Okay. Yeah. Everyone, please try to solve. So what is the chance, if I pick a person at random, what is the chance that the height will be between 4.5 to 6.5? Right? Okay, we'll give you 2 minutes of time, right? Write a code and check that. Okay, if you have an answer, please put it in the chat box. Okay, whatever percentage you get, whatever probability you get, please put it. Okay, another answer 60.31. Right, we'll see that as well. Okay, others?
Sir, I have one question, sir.
Yes, Manish.
Sir, in this normal function, we are using location is equal to 5.3. Sir, any reason behind putting 5.3?
Okay, let's go back and check the question. See this question. All right. There you see that they already mentioned that mean is equal to 5 point.
Got it.
That's the location where the curve exists, central point of the curve. Also, there is another value, that is standard deviation, but you need to specify the standard deviation in this format. Okay, location for mean, scale for the standard deviation. Okay, only that's the reason why we are using those values.
And sir, can you go backward?
Yeah, sure.
Same point. And so we have used here numpy arrange then 1, 10, 0, 0.01.
Yes.
So how we got this?
Again, that is left to me. I'm actually creating an array. NumPy array has to be created using np dot. Range is a function which creates all the values from 1 till 10 with the gap of 0.01. So 1, 1.01, 1.02, 1.03, etc. up to, right, 10. Okay, the only reason why created exactly 1 to 10 is that most of the height of adult, right? So no meaning in creating 0. There is no person with height 0, right? So started with 1. That's all. Okay. Yeah. Any other question or any other answers? I see only 2 answers. Yeah. Others, please try. I can give 2 more minutes. Please try, because it's already there, right? Everything is there, right? You just have to put some values, get an answer, and convert that answer into the required format. That's all, right? So I suggest everyone should try. Okay, doesn't matter what answer you get, that's fine. But please attempt it. So let's look at what I'm supposed to do when I try to write a code here, right? Our intention is that height should be between, say this is 4.5, say this is 6.5. The fundamental idea is that I am supposed to calculate this total area, that's all. Okay, those who didn't get what you're supposed to do, write a code so that you can calculate this. That's all. Okay, yeah. I want few more answers. Okay, so just to confirm that, okay, everybody is trying, right? So whoever is about to finish the code, right, please finish that in the next 30 seconds so that we can proceed further. Okay, put your answers in the chat. Not getting? Okay, no problem, Gaurav. We'll discuss. Okay. So the idea is that, yes, Ruchi says 0.67 probability, right? Absolutely fine. We'll see. So the idea is that when I type a code like this, right? That means it's going to calculate the area under the curve starting from minus infinity to that point. Let me say I already have calculated a 4.5. That gives me this area from minus infinity till this point, right? I also calculate another value with the 6.5 somewhere here, which actually gives me the value all the way from minus infinity to this number. That is 6.5. But you see what I want. I don't want whatever is already covered, right? That I need to subtract. This region, you have to subtract from the 6.5 value. Calculate something for 6.5 minus the same 5 of 4.5. Actually, we had calculated this equation, right? So I'll just erase this. So what is this? This is actually 5 of 4.5. That's all. From the table, we used to calculate 5 of something, right? But there we used to get only the values less than 3 because you were normalizing that. But in the programming part, you don't have to normalize, right? Machine still can able to calculate, right? By using the function CDF. So I am supposed to apply the same logic which we use, right, when we solved problems in the previous class. But the representation is slightly different. You will get other values also, not just within 3. Okay, any other value possible depending on where your function exists. That's all. Okay, all right. Yes, I think now I'll give, say, 1 minute of time. Those who didn't get earlier what you are supposed to do, and now you are able to do that, means yes, please go ahead, calculate and give the answer. I'll give you 1 minute of time. Okay. Yes. Yeah, I think the answer 67% or 0.67 is the closest one. Okay. Yes. So those whoever got that, yes, good job. Right. I think Somesh, just verify your answer once. It comes around 67, I guess. Okay.
Yes.
All right. All right. Yeah. Others? Yeah. Please try and try to get your answer. Yes, Ruchi.
Here we are considering this x value 4.5 and 6.5.
Yes. That's right. Yes, Prashanth also got 67.3, right? That's good. Now, let me define for 4.5, I get some value that I need to subtract from 6.5 value, 5 of 6.5. Okay, so I will write, right, 5 low corresponds to 4.5. Okay, so that is equal to norm, same PDF I should consider. So go for location. LOC is equal to 5.3. Okay, and scale should be equal to 1. Right? It's the same thing. But only thing I change is, okay, this is the same thing, right? Or you already have that. Okay, I could have simply pasted, right? Fine. So CDF of 4.5. Assign this to a variable. Similarly, calculate the phi. Let me call it as high. Okay, higher values correspond to 6.5. You can even write 4.46 over there. That's fine. Okay, so norm. So go for LOC, that is equal to, right, 5.3 comma scale being equal to 1 dot CDF 6. Okay, and the required answer is nothing but phi high minus phi low. Yeah, so you can see that 0.673074. Yes, already we have many answers close to that, right? So that's how you can calculate. So the writing a code is much more easier than doing the calculation, obviously, right? But the logic applied here is slightly different than what we solve. When we solve the problem, we need to convert this into a standard one, then you need to solve. Okay, that's because of the restriction that you cannot create a table for each and every position of the normal this thing. So convert that into standard so that you use a same table for any kind of given problem. All right. Okay. One more problem to solve. What's the question? Yeah. So is it always goes from minus infinity to positive, or it will change? It depends on where it exists, right? So if at all this value is on the, if the location of your curve is on the negative side, it can be minus infinity to a negative number. But always it will start from minus infinity, goes till a particular point. Okay. So there is a difference from the table version and what is being solved practically. Okay. So just understand that there we need to say that, okay, it is always calculated from 0 to some point. If you want to do the calculation from minus infinity to that point, add 0.5 to that. Now you don't have to do that. Okay. Automatically calculates every value from minus infinity to that point which you are writing over inside the brackets of CEF. I hope that is clear. Okay. So another question. Let's say okay. Right. Find the probability that height of a person randomly chosen will be more than 6.5 feet. Okay, everyone try. Similar logic. Once you have the answer, please put your answer in the chat. So let's look at what we are supposed to calculate. Maybe that is going to give some more idea about those who are still doing the problem. Okay, still trying to solve it. So there is what is called as 6.5. Maybe this is the value, right? More than 6.5 is what is being asked, right? So that is this area, right? More than that, how much is the area under this curve from 6.5 to infinity, right? So obviously if you are solving it manually, right, then I'm supposed to do an integration from 6.5 to infinity, whatever function we have here, we are solving that. Okay, so this is what is required. Okay, we'll give 30 seconds more so that others can put your answer. Yes, we have another answer from Priyankar as well as Gaurav. Same answer, right? 11.5% or 0.115. So already we have the high value here. Okay, right? So that's corresponding to 6.5. But since our intention is to calculate the value more than that, I am supposed to find out the total area. From that, I need to subtract this value, isn't it? So look at the concept we used earlier, right? Whenever we solve the problem using the table, if at all I have a value from, okay, I'll draw this. Okay, if at all we were solving this problem and we knew something which is at the center, so assume that that is 0. Okay, if I have a value here and I want to calculate the value more than that particular point, if I want to calculate this area, I knew that this total area is 0.5 from the center to the right side everywhere. If you consider all the points, that is equal to how much? 0.5. So corresponding to this 6.5, I get a value that actually corresponds to this area, right? So I used to subtract this value from the total value, that is 0.5. Okay, this was the logic when we were using the table to solve the standard normal distribution. Okay, all right. Now, in this particular case, we don't have that. We know only one thing, that is total area is always from minus infinity to plus infinity, and that value is equal to 1. That's the first thing you need to consider. Again, when I calculate something corresponds to say 6.5, right, like this, I always get the value from, right, minus infinity to this point. So that means what? If you want the other side, you need to subtract whatever value you get for 6.5 from 1. That's all. 1 minus 5 of 6.5 is the required answer. Okay, I hope that is clear. So let me write that. So I am looking for this answer. So this is 1 minus, right? So that's norm location equal to 5.3, right? And scale bin equal to 1 dot 6.5. All right, so you can see that, right? This is the required answer, right? So most of you have got that, right? That's good. So let's quickly go through another question. Again, I'm not going to solve it. You please try to solve by yourself, write a code and get the answer. Okay, so a quick thing to solve, right? I'll type the question. Okay, let's say marks obtained in exam follows, right? Normal distribution with the mean of 65 and standard deviation equal to say 8. Okay, if a student is picked at random, find the probability that, I will split the question into 3 parts. Marks obtained is less than 50, part say B of the question, marks obtained is between 55 to 70, part C of the question, marks obtained is more than 70. Okay, this is the question. Create the CDA, create the this thing. Well, again, plotting is optional. You don't have to go for a plot, right? Directly try to obtain the answers for A, B, and C separately. Okay, let me try to give a space here so that it comes in the new number, right? Yeah, so question is more clear, right? So obtain your answers and give your answers. All right, enter them in the chat box. Okay, so we have answers like 0.03 for A. Okay, let me write here, right? Just verify, right? Most of the answers, whatever I am getting, I'm trying to write that. Okay, so this answer comes approximately 0.03, I guess, right? 0.03. Few more values are also written. 0.0303. Okay, approximated to 0.03. That's fine. Okay, and I think the second one is approximately 0.6283. Is it? Okay. So 6283 approximated to 6.63 by few of you. That's also fine for us. And the last one, 1056, I guess, right? Okay, so 0.1056. Okay, so this is the answer we have so far, right? I think all the answer we got so far are matching. Okay, let me know if anybody has any doubt in the approach that you should use to solve this, right? And the code that you are going to write to solve this. Any doubt related to that? Yeah, please tell me. Or
Sir, what if we are having standard normal deviation distribution, and then we will put this LOC is 0, and then we have to use this CDF function or
CDF
PDF?
only. CDF only. CDF.
Oh, CDF only.
Yes, yes.
Okay.
Okay. So the logic remains same. Only thing that you change is the mean value becomes equal to 0 and the sigma value becoming equal to 1. That's all.
1. Yes.
Okay.
Okay.
So
Okay.
that gets any problem given gets converted into that if you want to go for a standard normal. Okay.
Thank you.
Yes. Yeah. Any other doubt? Okay, so I'll give you a big picture, right? What is the intention of studying all this, right? It's something like we have a data set, right? One more concept that is required will be covered under the probability concept. When we move on to the next module where we study the probability, things are going to be more clear, right? But as of now, we don't know that. But let me tell you something. There is what is called as a central limit theorem, which says that if you have a huge number of data points, right? Not like very less, not 1,000, not 2,000 or something. Let's say I have 5 lakh or 10 lakh. In such case, the distribution, whatever you get, right, is always the normal one only. That's why I was stressing always about this normal. We spent a lot of time on normal just because of one reason. Okay, so that the reason is that when you have a huge data points, huge number of data points, right, the distribution is always very close to the normal. It can be simple normal, standard normal, doesn't matter, right? It will come back. So now that means anyway, ultimately we are going to deal with the huge data sets only, right? So for that reason, right, we should know if I have a data. Without knowing that it is normal, you still can apply everything we studied for normal, because there is a theorem which says that, which actually has been proved. Central limit theorem says that irrespective of your original original distribution, I had say just 10 data points or 100 or 1,000, right? It followed some other distribution, doesn't matter which one. But if you do keep repeating the same experiment and you keep collecting more and more data points, right? Whatever distribution you might have earlier, right? That will tend to become a normal curve, right? So that's the ultimate point. We'll see that later. Maybe if possible, programming, by using a programming, we'll try to prove that as well. Okay, mathematically we are not going to touch that. It's a proved thing. Okay, so that's one. So data set is given. If you have huge number of data points, it's a normal, close to normal. Now that means I should be able to extract more things from that, depending upon what problem I'm looking for. I may have to find out what is the percentage or what is the probability that, okay, in this curve, this is happening. Right? What is the chance that this is going to be more than this, etc. It is, we need to calculate. So we are gathering the information, how that happens, first thing, and how to code that. 2 things we have studied so far. Okay, that was what the intention behind teaching all these techniques so far. All right, so I hope things are getting easier for you now, and as we progress, you are going to learn more and more things. But all these concepts, whatever we have studied, are the basics of whatever is required at a higher stage only. Okay, anything you want to discuss, please go ahead. Otherwise, we have come to. Yes, please.
So if we don't know about the distribution of our data, and for the same problem, we are just using binomial Let us say we are using binomial distribution.
Okay.
And can we use the same formula like dot CDF for that?
Yes, dot CDF will work for anything. You only the normal, only the distribution you need to change. Okay.
Okay.
You can go for
Yes.
Poissons, you can go for
Perfect.
binomial,
Yes.
you can go for any other thing. Okay. Everything is same, right? So we didn't touch that much because, right, when you go for a big data, bigger size of data set, this is what will be the ultimate.